33 incredible energy experiments, subtle methods, best discoveries. Welcome to our channel. Today we're diving into the fascinating world of energy experiments. You know, the kind of experiments that make you question everything you thought you knew about the universe. From historical breakthroughs to modern-day applications, these experiments have shaped our understanding of the universe. We're talking about the experiments that revealed the secrets of the atom, unlocked the power of electricity, and continue to push the boundaries of physics. Get ready for a mind-blowing journey as we explore 33 incredible energy experiments. Let's get started. Chapter 1. The double-slit experiment. It's like the universe is playing peekaboo with reality. Buckle up, we're entering the quantum realm with the double-slit experiment. Imagine shining a flashlight through two slits in a wall. You'd expect to see two bright spots, right? That's classical physics, but here's where it gets weird. Fire electrons, and they create an interference pattern, like waves interfering with each other. But it gets weirder. Observe the electrons, and the pattern disappears. It's like the universe knows we're watching. This experiment baffles physicists and is central to quantum mechanics. Chapter 2. A blast from the past, the history of the double-slit experiment. This experiment has a long history dating back to the early days of physics. In 1801, Thomas Young demonstrated the wave nature of light using the double-slit experiment. Sunlight passing through two pinholes created an interference pattern, proving light behaves like a wave. In the 20th century, physicists experimented with particles like electrons. In 1927, Davison and Germer showed electrons could create diffraction patterns like waves. This confirmed the wave-particle duality of matter, a key concept in quantum mechanics. The real mystery came with detectors observing which slit electrons passed through. Observations seemed to collapse the wave function, forcing electrons to choose a single path. This phenomenon has sparked countless debates and interpretations ever since. Chapter 3. What does it all mean? Unpacking the key findings. The double-slit experiment isn't just some esoteric physics puzzle, it has profound implications for our understanding of reality. The key takeaway is that particles like electrons and photons can exhibit both wave-like and particle-like behavior. This wave-particle duality is a fundamental principle of quantum mechanics, and it challenges our classical intuitions about how the world works. Another crucial finding is that the act of observation affects the outcome of the experiment. This suggests that consciousness, or at least the act of measurement, plays a role in shaping quantum reality. This interpretation, known as the Copenhagen interpretation, is still the most widely accepted explanation for the double-slit experiment. But it's not without its critics, and alternative interpretations, such as the Many-Worlds interpretation, continue to be explored. Chapter 4. The implications, from quantum computing to the nature of reality. The implications of the double-slit experiment extend far beyond the laboratory. It has had a profound impact on our understanding of physics, philosophy, and even the nature of reality itself. In the realm of technology, the principles of quantum mechanics, as revealed by the double-slit experiment, have led to the development of transistors, lasers, and other essential technologies. Quantum computing, which harnesses the strangeness of the quantum world to perform calculations impossible for classical computers, is another exciting area of research. But the implications go far beyond practical applications. The double-slit experiment forces us to confront fundamental questions about the nature of reality, consciousness, and the role of the observer in the universe. It challenges our deterministic view of the world and suggests that randomness and uncertainty may be fundamental aspects of reality. Chapter 5. A universe of opinions, different interpretations of the double-slit experiment. Now, the double-slit experiment is like that friend who tells a wild story, and everyone has their own interpretation. Some physicists believe it demonstrates the fundamental uncertainty in nature, where particles exist in a superposition of states until observed. Others argue it shows the limitations of human perception and measurement, suggesting we can never truly know the reality beyond our observations. Then there's the Many-Worlds interpretation, which takes a rather dramatic approach. It proposes that every quantum measurement causes the universe to split, with each possible outcome occurring in a separate, parallel universe. Talk about a mind-bending concept. The debate continues, and no single interpretation has been universally accepted. But that's the beauty of science. It keeps us asking questions and searching for deeper truths. Chapter 6. From Lab to Life Practical Applications of the Double-Slit Experiment. You might be thinking, this is all fascinating, but how does it affect my life? Well, the double-slit experiment, for all its strangeness, has led to some pretty amazing practical applications. Take quantum computing, for example. By harnessing the principles of superposition and entanglement, scientists are developing computers capable of solving problems that would take classical computers billions of years. This has the potential to revolutionize fields like medicine, materials science, and artificial intelligence. Then there's cryptography. Quantum cryptography uses the principles of quantum mechanics to create unbreakable encryption, ensuring secure communication in an increasingly interconnected world. Even medical imaging techniques like electron microscopy rely on the wave-like behavior of electrons, as demonstrated by the double-slit experiment, to visualize objects at the atomic scale. The story of the double-slit experiment is far from over. Researchers around the world are still conducting experiments pushing the boundaries of our understanding of quantum mechanics. One area of active research is exploring the double-slit experiment with larger and more complex particles. Can we observe wave-particle duality in molecules or even tiny living organisms? Another focus is on the role of entanglement, where two particles become linked, even at vast distances. Understanding entanglement could hold the key to developing even more powerful quantum technologies. And then there's the ultimate challenge: reconciling quantum mechanics with Einstein's general relativity, which describes gravity. Finding a unified theory that explains both the quantum world and the cosmos is one of the biggest challenges in modern physics. Chapter 8. Pondering the profound philosophical implications of the double-slit experiment. The double-slit experiment isn't just a physics experiment, it's a philosophical enigma. It forces us to confront fundamental questions about the nature of reality, consciousness, and the role of the observer in the universe. Does the act of observation create reality, or is there an objective reality independent of our perception? Does the universe have a predetermined path, or is it inherently probabilistic? These are questions that have puzzled philosophers for centuries, and the double-slit experiment adds a whole new layer of complexity. Some argue that it supports the idea of a participatory universe, where consciousness plays an active role in shaping reality. Others see it as evidence of the limitations of our classical intuitions and the need for a radical new understanding of the cosmos. Chapter 9. Quantum 101. The educational value of the double-slit experiment. The double-slit experiment is more than just a mind-bending experiment, it's a powerful teaching tool. It's often used as an introduction to quantum mechanics in physics courses, captivating students with its counterintuitive results. By demonstrating the wave-particle duality of matter and the observer effect, it challenges students to think beyond classical physics and embrace the strangeness of the quantum world. The experiment also highlights the importance of critical thinking and questioning assumptions. It encourages students to consider different interpretations, evaluate evidence, and develop their own understanding of complex scientific concepts. In a world increasingly driven by technology rooted in quantum mechanics, understanding the fundamental principles revealed by the double-slit experiment is more important than ever. Chapter 10. The never-ending debate: criticisms and alternatives to the standard interpretation. Of course, no scientific theory is without its critics, and the double-slit experiment is no exception. Some physicists propose alternative explanations, such as pilot wave theory, which suggests that particles are guided by hidden waves. Others argue that the standard interpretation of the experiment is oversimplified and doesn't fully account for all the observed phenomena. Some critics point to the role of the measuring apparatus, arguing that it's not consciousness that collapses the wave function, but rather the interaction with the physical environment. This debate is healthy and essential to the progress of science. By questioning assumptions, exploring alternative explanations, and conducting new experiments, we refine our understanding of the universe and edge closer to a more complete picture of reality. Until next time, keep exploring the wonders of science. Thanks for watching. We've journeyed from the classical world to the quantum realm, explored mind-bending experiments, and confronted profound questions about the nature of reality. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating insights into the world of science. Remember, the universe is full of mysteries waiting to be unraveled. So keep asking questions, stay curious, and never stop exploring. See you next time. You next.